Hello, geometry students, to our very last day, our very last section of, it's day 1, but our very last section of chapter 10, which is all about spheres. We'll do another day 2 where we talk about spheres and composite figures, for example, like a hemisphere stuck to a cylinder or something, and then we will prepare for our chapter 10 summative. So our essential question today talks about spheres. Can I find the surface area and volume of a sphere? And technically hemisphere, but I'm just going to put a sphere there instead of a hemisphere because it's just part of a sphere. So the first thing we need to know is, how do you find the volume? How do you find the surface area? Meaning, what formula do I use? How do I go about this? You do not have to memorize those. Those will always be given to you. If you don't have your formula sheet at home, now would be the time to write them down. We're going to write them in our notes. The best part about Google is that exists, so you can look that up. The only thing you need to know is how to use it. For example, on ACT tests, on final exams in the future, we're not going to take one this year, obviously, but when we're looking at formulas, you just need to know how to use them. So they'll be given to you. So let's practice how to use them. The volume of a sphere is 4/3 pi r cubed, and I kind of did that. I looked away from my formula sheet and I was like, oh, I know it's r cubed because it's volume, and volume is cubed, so the volume has an r cubed. The surface area is 4 pi r squared because area is squared, so that's a good way of memorizing it. So we're just gonna do 2 examples. We'll do one with a sphere and one with a hemisphere. Example 1, we're gonna draw a sphere. This is usually pretty easy, but let's try it together. You have a circle, I've drawn better circles, that's okay. And you're going to draw this hemisphere line here, whereas if you were to cut it in half. So we're going to draw the front part, and then the back part kind of looks like that. Like if you were to draw the inside of a cone. So hey, could look worse. I don't hate that. Now I'm going to give you, your radius is 9 centimeters, and that's how it will be drawn. Usually it's in this 3D shape. Obviously it'll be better because it'll be printed for you. Or they could just say, hey, it's a sphere with a radius of 9. They don't even have to give you a drawing. In fact, I'll write this out. Sphere with radius of 9. I would like you to find the volume, and I would like you to find the surface area. And we're going to use our area down, or a space down here, to actually find them or solve for that. So for the volume, it's 4/3 pi r cubed, 4/3 pi r cubed. I'm going to plug in r. My suggestion is to write this down every time, even if these are kind of easy problems, but you don't have to do that. The volume is 4/3 pi r is 9. That was given to us, and then we're done. Normally we're looking for slant heights and we're doing all this stuff, and at this point you could either type in 4/3 times 9 cubed and you would get 972 pi centimeters cubed. That would be your exact answer. Or if I said, hey, give me your rounded answer, you would type all of that into your calculator. You can type it in exactly as you see it. Make sure to put those 4/3 in parentheses if you do just type everything into your calculator, and you'll get 3,053.63 centimeters cubed. I'm going to emphasize that those are both correct answers. And in fact, I'll even write that down, that this is the exact answer, because no one could argue with me. I'd say it's 972 pi, and you'd say, yep, that's exactly what I got. And this is rounded. The reason that rounded is not as exact is because you could argue with me and say, actually, it's 3,053.6. And a friend might have rounded to the nearest hundredth, or 1,000th, or 10,000th. So rounded is just that, rounded, and not exact. All right, our surface area, so I guess I didn't say what it is, so let's just put it in as rounded. It's always best, I think, to at least put 2 decimal places, to at least put it to the nearest hundredth, but The nearest tenth would be fine. Because I didn't tell you how to round it, so you could do whatever you wanted. 4 pi r squared. The best part about spheres is you only need a radius, and that was given to you. So plug that in. At that point, if I asked you for exact answers, you would type in 4 times 9 squared, and you would get 324 pi. What is it? Centimeters squared. Or if I asked you for the exact answer, you would type all that in, including the pi, multiply it by the pi, and you would get 1017.88 centimeters squared. And again, both of those are correct. One of them is rounded, and the other one is the exact answer. So let me write that right here. 1017.88 centimeters squared. And those would be your answers for those. I'm going to do another example. Example 2 is going to be a hemisphere. What makes this problem a little bit different is that you can't just cut the volume in half and be done. Well, in fact, you can do that for the volume, sorry. But the surface area, you can't just cut it in half. Because if I was to ask you for the volume, and I said, here's the volume of a sphere, I would like you to find half of it, you would just cut it in half. So the volume is actually going to be easier to find for the hemisphere. You just find it, cut it in half. Whereas the surface area, if I asked you to cut the hemisphere in half, there's no like cover to this, there's no base to this. So when I ask you to find the surface area of the hemisphere, you cut the surface area in half, but you need to add in, I picked the wrong side, you need to add in a base to that. So if I asked you to find the surface of a hemisphere, you'd find the surface area of a sphere, but you gotta add this little circle base there. So let's look at an example that uses those skills here. Best way to draw a hemisphere is to give yourself a little half circle, and then give yourself like the end of a cone, like a bubble, and then the back bubble. That's clearly not a perfect hemisphere, but we're gonna go with it. In this case, our diameter is 24 inches. And that's technically all you need, because all you need is the radius, and if I give you the diameter, the radius will be given to you. So the radius is 12. Always really helpful to just write that down, even if it seems obvious, even if you're like, well, I can just keep looking back at it. I know the radius is 12. It would never harm you to write that down. So we are looking for the volume, and we are looking for the surface area. We're going to use all this space down here to actually show our work or do our thinking for us. Here's the deal with the volume and the surface area. I'm going to tell you right now, it's given to you. A hemisphere, half of a sphere. Well, look, half of the volume is half of it. Half of 4/3 is 2/3. Half of 4 is 2. So the volume is pretty easy. You just find the volume, cut it in half, or use this formula. The surface area looks a little bit different because what they did is they took 4 pi r squared. That would be I've got to use my pictures here. That would be the whole thing. They cut it in half, which would be 2 pi r squared. But then look at what they had to add. They had to add a circle, which is pi r squared. So that's why they got 3 pi r squared, because they cut it in half, and then they had to add that circle right there. So normally, like I'd say, okay, the surface area is a little bit more difficult because you have to like find half of it and then add a half circle, which is totally fine, but it's given to you, and if it's given to you, just use it. You don't have to worry about that. So the volume is 2/3 pi r cubed. The surface area is 3 pi r squared. I know that I left those spaces for our answers, so we'll just put our answers down here. Whoopsies. And I'm going to show my work down here, or show my thinking. So in this case, my volume is 2/3 pi, and what's my radius? 12 cubed. That's my volume. Just gonna plug it in. Now, like I said, if I'm looking for the exact answer, I do need you to know how to do this. You would multiply 2/3 times 12 to the power of 3, and you would get 1,152 pi. So that's not including the pi when you just type in the constants out there, the coefficients, and that's inches cubed. But if I was asking for the rounded answer, which I normally am, that would be 3,619 0.11, and I think it's like 114 or something, but technically we'd round down. So at this case we have inches cubed. We have two answers. One is exact and one is rounded. I normally ask you for rounded, so that's what I'm going to put up here. 3,619.11 inches cubed. And then the other thing we're looking for is surface area. It's given right here. Just plug in what you know. So our surface area is 3 pi 12 squared. If you're looking for the exact answer, just multiply 3 and 12 squared, and you will get 432 pi inches squared. But more than likely, I'm going to ask you for it rounded, which is 1,357.17 inches squared. My reminder as I'm finishing up this problem to you right now is to make sure to really read the instructions. Does it ask you to use 3.14 as pi? Does it ask you to round it? Does it ask you for exact answers? Does it ask you to round it to the nearest hundredth, or does it ask for the nearest tenth? So be very careful when you're reading the instructions today. Otherwise, I think you are all ready to go.